All right, folks. Hello, everyone. Welcome to episode 3 of the Sdet interview masterclass, the advanced level. If you have mastered the intermediate topics, this episode will show you how to design enterprise grade test systems, cloud native, scalable, secure, and AI enhanced. As most of you already know, I'm Siddhant Wadhwani, your guide come mentor through this episode to prep you with the interview questions and respond with the perfect answers. We'll delve deep into architecture, CI/CD integration for performance test, AI approaches for flaky test, security automation, test data at scale, and how to plug generative and agentic AI into your dev test ops workflow. So let's begin. The first question is, how would you architect a scalable cloud native test automation framework for a global product? Now, designing for global scale means the framework must be modular, cloud native, containerized, and observable. So what I use is a layered architecture. It starts with test layer or the test scripts as the source. The tests are organized by domains, whether it's unit or contract test, integration, API, UI, performance. Use language agnostic tools. So Playwright for web, PyTest or JUnit for services, and K6 for performance, for example. Next, move on to performance and framework as a code. Focus on page objects, component libraries, shared utilities, auth helpers or test data adapters in that sense, and SDKs, exposing test primitives. Make sure that you're keeping the repo small and versioned. Then we come to the runner layer. That's where you have containerized test runners like Docker images that execute your tests. Build images with the runtime and the dependencies and push it to a registry. For parallelism, use Kubernetes jobs or cron jobs or a runner autoscaler. Next, we come into the orchestration layer. So there you have Kubernetes, GitOps, or you can use Argo CD to manage test infrastructure. For heavy parallelism, use a job queue, whether it's Celery or Kubernetes batch, and horizontal pod autoscaling. Then we come into storage and artifacts. You can use S3 buckets, blob storage for videos, logs, or traces. Use the ELK stack or Loki for logs and store structured test results inside a database for analytics. Then, talking about reporting and observability or insights, you can use Allure, Report Portal, or several other reporting dashboards for test results. You can also leverage Grafana dashboards for performance trends, tracing with Jagger or OpenTelemetry for distributed debugging. And don't forget security and secrets. You can use a HashiCorp Vault or Kubernetes secrets to manage your credentials and rotate them automatically. Let's take an example of a Kubernetes job to run Playwright tests in parallel. I've just created a simple job that does parallel testing for your Kubernetes. Don't forget to also focus on non-functional aspects like idempotent test, ephemeral environment provisioning, and locality or environment-based, cloud region-based testing. And also cost controls where you look at auto scaling, whether you're scaling up or scaling down your resources or idle runners. A pro tip here would be keep your test code and the infrastructure as a code version, test images, and orchestration so you can reproduce any historical run. Also, maintain a canary test subset that runs in production like Windows to detect regressions early. Question 2. How do you ensure load, performance, and scalability testing are integrated into your CI/CD? Well, you want performance testing to be continuous and risk aware, not an isolated weekend exercise. So my approach here is more of tiered testing and pipeline, where you have PR level, nightly, or pre-release canary checks. When we talk about PR level, very small smoke performance checks, where it could be single virtual user for a short duration, which will help catch instant regressions. Nightly, where it's a large scenario, you can run tens of thousands of virtual users to catch regressions and baseline metrics. Pre-release or canary, where you have full-scale load tests simulating production-like behaviors to analyze your traffic patterns. Next, use appropriate tooling. Now, whether you consider JMeter, Locust, or K6, K6 is in that sense great for scriptable JavaScript based scenarios, Gatling or Locust for Pythonic workflows, and JMeter if you need broad plugin support. So make sure that you're storing those scripts under source control. Next, CI integration. Add performance jobs in GitHub Actions or Jenkins or whichever CI mechanism you use that call the selected runner or spin up a dedicated load test namespace in Kubernetes. Post those results into Grafana via InfluxDB or Prometheus adapter. Baseline and SLOs. Keep the baselines in a metric store and set thresholds like service level objectives, SLOs. If a pipeline run breaches SLOs, that is like P95 latency spike, or the error rate is greater than the threshold, mark the build as failed. Talking about test data and environment parity. Use production-like data and network conditions. For global products, run tests from multiple regions. Use cloud regions or synthetic canaries to capture geo variance. Last but not the least, cost safety. Don't run full destructive load test against production unless scheduled and gated. You can use canary environments or throttle tests. So a pro tip here is automate performance aggressions detection. Use statistical comparisons, for example, Bayesian change point detection, instead of simple thresholds to reduce the noise. You can also store artifacts in the form of heap profiles or flame graphs when regressions occur for developer triage. Third, how do you detect and fix flaky tests using AI-powered solutions? Now, flaky tests come from timing, async behavior, environment flakiness, or test design. AI doesn't magically fix all of them, but it accelerates the detection, the root cause analysis, and even remediation. So, talking about detection and triage, you can use the historical run data to build models of pass or fail patterns. Tools like Launchable, Testim, or several others, which use custom ML models, can calculate the failure probability and highlight the flakiness or the flaky candidates. AI can detect non-deterministic patterns and tests that fail intermittently without code changes. Talking about root cause analysis, AI correlates failures with environmental metrics or measures in the form of CPU, network errors, or likewise. Moreover, recent code changes with Git differences and log patterns. An LLM augmented with run artifacts can produce an RCA summary like this test failed due to network timeout, approximately 200 milliseconds coinciding with elevated API latency. Auto-suggest and auto-fix. For locator flakiness, AI can propose alternate selectors like semantic text, role, or neighbors, or suggest inserting explicit weights where appropriate. Tools like Selenium, Mabel, Testim, or several others do locator-based healing, whether you call it self-healing, auto-healing, but it helps reduce the flakiness. For timing issues, AI may recommend replacing brittle sleep calls with event-based waiting. That is, you can use wait for response, wait for selector, or wait until keyword succeeds, or likewise. Talking about agentic remediation. An agent can open a PR with suggested fixes, update selectors, add a wait, or mark a test flaky, and include test evidence and rationale. This PR is then reviewed by an Sdet. You can look at this example. I've just taken a pseudo flow. So detect flaky, you pass the test ID, collect those artifacts, and then you have an LLM that generates the fix suggestions, and you open a PR with the patch. But remember, you have some cautions here. Automated fixes should be human reviewed. Always maintain an audit trail of automated changes. A pro tip, combine AI with guardrails. Auto suggest fixes, but it requires a human intervention to approve and merge, at least until confidence and coverage are mature. Also, proactively design tests to minimize the flakiness. Idempotent operations, control test data, and service mocks where necessary. How do you incorporate security testing into your automation pipeline? Shift left security. integrate security scans in the same CI/CD flow with staged intensity. How can you do that? Dependency and SCA. I'm sure you've heard of these. Run sync, uh, run SNCC or depend a bot on PRs to catch vulnerable libraries early. Fail the build on critical vulnerabilities. You can also do static analysis, SAST, or dynamic application security testing, that's DAST. For SAST, you have tools like SemGrep, SonarQube, which you can incorporate in your PR checks for obvious injections or insecure usage patterns. Talking about DAST, you have Veracode, OWASP Zap, Burp Suite, which come into automated mode. For example, a Zap baseline run Docker. You can use docker run -t OWASP and then just pass in your baseline.py file and ask it to run against the URL and export your report into a .html file. Talking about API security, run API fuzzing and contract checks. Use tools that support JWT or OAuth flows. Infrastructure scanning. IAC checks. You have Terraform, CloudFormation with Chekhov or TFSec in your continuous integration. Orchestration and gating. You can put security scans in PRs as quick checks and run deep DAST and pen test flows in nightly or pre-release windows. If DAST finds high severity, then block the release until triaged. Now, the most important one, automation of remediation suggestions. Tools often provide fixed suggestions that can be turned into issues for developers. So, a pro tip here, maintain separate credentials and tightly control your scanning scopes. Integrate security findings into backlog and prioritize by business impact, not only by severity. Also, correlate security alerts with functional test failures to speed up the triage. How do you manage test data at scale, including synthetic test data generation with AI? Well, managing test data at scale is a pain. Test data strategy must balance realism, speed, privacy, and reproducibility. That's where I have a different layers of approach to this one. Starting with synthetic data generation, you can use the Faker or factory libraries for simple use cases. For realistic patterns, use AI models that are trained on anonymized or aggregated schema to produce believable data sets. For example, address, names, multilingual input, or edge cases. Focus on data masking and anonymization. If you must use production data, then apply deterministic masking. That is, preserve the format, scramble values, and remove PII. Use tools like AirCloak or in-house masking pipelines. Ephemeral provisioning. For parallel test, provision unique test entities via API seeders or database snapshots. Use transaction rollbacks or containerized databases for fast resets. Data catalog and governance. Maintain a catalog of datasets with metadata. That means your size, the sensitivity, the refresh rates, all at once. Automate the refresh cycles and retention policies. AI for edge cases. Use LLMs to generate corner case datasets. For example, name with emoji, right to left text, unusual Unicode character strings. This finds parsing serialization bugs early. And last but not the least, scaling and storage. You can store large datasets in cloud object storages like S3 buckets and let your CI runners pull subsets based on the test scope. For compliance, encrypt the data and in transit. A tip here is build a test data service, whether it's a small microservice that provides unique idempotent test objects via REST APIs for test runners. What this does is it centralizes the provisioning and reduces the collision in parallel runs. How do you integrate generative AI and agentic AI into a full dev test ops pipeline? Let's talk about the present and the future, generative AI and agentic systems. Integrating generative AI and agentic AI is about augmenting human workflows while keeping safety, traceability, and governance in place. You have tons of use cases, but we'll look into some of the most important ones. Test generation. LLMs convert user stories or acceptance criteria into draft test cases. So you can obtain these requirements from multiple input sources, whether it's through requirement documents, Figma designs, design documents, or you have Jira, Confluence, XYZ factors, or you just provide a prompt. It can convert, like be context aware and provide those into test case formats, whether it's Gherkin or code in general. Next, test maintenance. Agents suggest locator fixes or refactors flaky test and opens PRs with differences and rationale. Test selection and prioritization. Agents pick the most relevant test based on the code differences and the historical failure risk. Autonomous test execution. Agentic systems can triage a failing build, run focused diagnostics, that is, collecting the logs, running impacted tests where necessary, and recommending whether a rollback is required or a hotfix. So that's all about use cases. But think about the integration pattern. So here, I'm sure you have heard about event-driven architecture. On PR open or commit, an event triggers an AI service that analyzes the differences and suggests test actions. Human in the loop. AI opens suggested PRs or creates issues rather than auto-merging critical changes. What this does is it provides reviewers with generated rationale and artifacts. And lastly, audit and explainability. Here, keep logs of AI decisions and the training data that was used, provenance for compliance. So on PR, what agents do is agent will analyze the differences, suggest maybe 5 tests, create those test scaffolding inside the branches like AI/test/the PR ID. It opens a PR with a message and attaches the failing traces. And human is then in the loop where your human reviews and merges the code. But mind you, factor in the operational safety as well, like rate limit autonomous actions, require approvals for production impacting changes, and test AI agents in a sandbox before giving them broader powers. Also, limit AI model access to sanitized datasets to avoid leakage. That takes care of your privacy and security concerns. So, a pro tip on how to approach this here is you start small, use generative AI for scaffolding and test suggestions, not autonomous deployed discussions. As confidence and governance improve, expand the agent's responsibilities like self-healing locators and prioritizing the test selection based on the most impactful areas or the historical test data. The ROI from this is huge. Faster triage, fewer flaky tests, and more focused test coverage. And there you have it, a packed session. We have just walked through some of the most cutting-edge Sdet concepts in 2025. From architecting scalable cloud-native test automation frameworks to integrating generative AI and agentic AI into dev desktops. We didn't just scratch the surface. We went deep into real-world strategies that companies are actually using right now, designing test infra as a code and treating automation as the byproduct. Automating the right test with TIA and SLOs. Don't aim for 100% coverage blindly. Use AI for augmentation, detection, suggestions, and prioritization, but keep humans in the loop for high risk changes. And finally, instrument everything. Observability is definitely your fast path from failing test to root cause. So, thank you so much, everyone, for staying tuned until the end. If you take away just one thing from this episode, let it be this: the future of SDET isn't just about writing tests, it's about engineering quality at scale, embedding intelligence into every stage of the pipeline, and being the bridge between development, operations, and innovation. So, whether you're preparing for a high stakes interview, leveling up your automation game, or aiming to be the tech leader in your team, start implementing these strategies today. If this video sparked ideas or gave you an aha moment, drop your thoughts in the comments. I read every single one. And don't forget, there's a beginner and intermediate episode packed with equally valuable insights. So make sure you watch those if you haven't already. This is Siddhant Vadhwani, helping you master the art and science of being an SDET in the AI driven era. So until next time, Keep testing smarter, keep building better, and stay ahead of the curve. Thanks for watching. See you in the next deep dive.